Number 37, page 142, bike assembly time. We're told that, let's draw a picture of what's going on. The bike assembly times for the customers are approximately normally distributed with an average of 1.29 hours, but standard deviation is as yet unknown, but they give us some big clues. So here's 1.29 on the normal model, and we're told that 25% takes 1 hour. So 25% of the customers can assemble the bikes in 1 hour or less. Well, we know that 1 hour is 2/3 sigmas. So if we use the formula, or it has a z-score of 2/3, z equals y minus mu over sigma, and solve for sigma. Sigma equals y minus mu, y minus mu over z. So sigma will equal 1 minus 1.29 over 2/3, which equals negative 0.29 over, it's negative 2/3, negative 2/3. And so let's do that in a calculator. So I've got negative 0.29 divided by parenthesis negative 2/3, and I get 0.435, which is standard deviation. So my normal distribution is approximately normal. 1.29, this is hours, 0.435 hours. Now notice, this isn't minutes. This isn't an hour and 29 minutes. This isn't 43.5 minutes or whatever. This is a decimal proportion of hours. If you wanted to get minutes, you would take 1.29 and multiply it by 60. Same with the 0.435. All right, part B. I'm going to go to the next page, actually, to see all the questions. Okay. Change the... they could solve this problem by changing the advertising claim so that 60% of the customers succeed in finishing by, they want to know how long it takes for 60% of the customers to assemble the bike. So we got 1.29 here. Sigma equals 0.435. We want to know about 0.6 percentile, and so we want to know the z-score that goes with that. So we'll do an inverse norm, second, and vars, an inverse norm 0.6. And so the percentile, the z-score that goes with the 60th percentile is 0.253. Okay, and so we want to know what that y value is that goes with that. Well, it's going to be 1.29, it'll be the mean, plus the z-score times the standard deviation, plus 0.253 times 0.435. Why is that? Well, if you take z equals y minus mu over sigma, and then you solve for y, you get mu minus sigma z equals y. Now, I'm sorry, yeah, mu plus sigma z equals y. Should have done all the algebra. Multiply both sides by sigma, you get sigma z, y, get y minus mu, add mu to both sides, mu plus sigma z equals y. Okay, so that's what I have here, and we take it, so we take 1.29 plus 0.253 times 0.435, and we get 1.4 hours, 1 4/10 hours. So the company can say 60% of the customers will finish the bike in 1.4 hours. Now, they want to come up with a claim of less than an hour. So they revise the instruction and label the parts better. And so they hope to move the 60% not to be 1.4, but they want this to be 1 hour. Now, they say the standard deviation is going to stay the same. So the standard deviation will stay, sigma is going to equal 0.435. So if the standard deviation stays the same, then the mean has got to get smaller. If 60%, if the 60th percentile is going to be 1 hour, then the mean, which is the 50th percentile, has got to be smaller. And right now, the mean, the 50th percentile, is 1.29 hours. So something's got to give. The standard deviation stays the same. Then, well, even if it got a lot smaller, the mean would still have to get smaller because 1 hour is less than 1.29. So we need a new mu. All right, so we're going to take z equals y minus mu over sigma, and we're going to solve it for mu. We multiply both sides by sigma. Sigma z equals y minus mu. Add mu to both sides and subtract sigma z from both sides. Mu equals y minus sigma z. All right, so anyway, we're going to do that. So y is 1, okay, and sigma is 0.435, and z, the z-score that goes with 60%, is 0.253. And so we worked that out with the calculator. And we'll take 1 minus 0.435 times 0.253. And so now we have a new mean of 0.89 hours. All right, so that's that takes care of C, and then there's finally this part D. Now let's talk about 0.89 hours. That equals, let's say 0.89. We'll take the answer times 60. Okay, so that's 53. Let's call it 53.4 minutes. Approximately equals 53.4 minutes. All right. Now, they say here they only got the mean down to 55 minutes. Nevertheless, they got the 60% in an hour goal. Well, how is that possible? Well, then they must have made the standard deviation smaller in order for 1 hour to be the 60th percentile with a z-score of 0.253 z's and a mean of 55 over 60 hours, then the standard deviation would have to get smaller. in order if you have enough standard deviations in between 55 minutes, 55 over 60 hours, and between 0 standard deviations and 0.25 and 1 hour in order to have 0.253 standard deviations. So sigma would have to get smaller. So we take z equals y minus mu over sigma. Sigma equals y minus mu over z. So what do we have? Y is 1 hour. Okay, mu is 55 over 60. And the z-score is 0.253. Okay, and we solve that and we'll get our standard deviation. That will give us approximately 60% of the customers assembling the materials in an hour or less. So let me open this parenthesis. Okay, there's the numerator, 1 minus 55 over 60 divided by 0.253. Okay, and we get, let's call it approximately equal to 0.329. So sigma is approximately equal to 0.329. So that's the standard deviation with a mean of 55 minutes. That would give you a 60 percentile of the customers assembling the bicycle in 1 hour or less.